Hello, Form 4s of 2020 and also Form 3s of 2020. Today we are going to discuss about mathematical concept of Form 4, which is differentiation. Remember, I'll be taking for you this week, God willing, videos concerning about calculus, that is the likes of differentiation, integration, and area and approximation. Don't forget, those things are very, very rampant even at university level when you go. Okay, when you join university, I'm sure they will also be there in your exams. So differentiation is not that much hard, by the way, and it's very, very rampant in case you see. Okay. Now we will start with the differentiating the equation of a curve. Okay. Then followed by getting the equation of a tangent and normal to the curve. Okay. Then followed by what we normally call testing stationary points. Then we move like that. Yeah, go reading, curve sketching as well. Then to start with that, let us start differentiation. Yeah, let's take example 1. Let's take example 1. You are told differentiate the following. Differentiate the following functions. Differentiate the following functions with respect to x. With respect to x. With respect to x. So this is what we are having. The first one is what? Before I go into this, before I go starting differentiating the equation of a curve, for your information, if the equation of the curve is actually having this kind of format, if you have, maybe let's say it can have this format, ax power n, so you can say this can be differentiated by saying n multiplied by ax n less 1. Look at that. Look at that. So we are multiplying by the power and subtracting 1 from the power. Just understand that. We are multiplying by the power and subtracting 1 from the power. It's very easy. So it was what? A x power n. Okay? Like let's say we have y is equal to 3x power 4. We want to differentiate this one. So what are we going to do? We are going to multiply by the power as a coefficient, then subtract 1 from the power. So we are going to say 4 times 3x power 4 less 1. Look at that. What are we doing? We are multiplying by the power and subtracting 1 from the power. Just understand. Very easy, by the way. Form 4 mathematics is very, very easy, my class. Remember, we are done with the statistics. Go back to our YouTube channel. This time, we are going to do this thing called calculus. Yeah, that's differentiation, integration, area, and approximation. Yeah, just understand. Okay, and here it will be what? 4 times 3 is what? 12x power 3. So what are we doing? We are multiplying by the power and subtracting from the power. We are subtracting 1 from the power. Just understand. We are multiplying by the power and subtracting 1 from the power. Very easy statement. Okay? So in the event where you are given the equation of a curve, let's say like this one. Let's say this one. You are told like when you have this is what you are having. This is what you are having. A is 2x power 3 minus 8x. Minus what? Minus 8x. Okay? Here, there's one hidden knowledge here. Remember, this x is having power of what? Power of 3. But the x which is attached to 8 doesn't have any power. But remember, we have one which is what? Which is hidden on top of x. So x alone, because we said any number standing alone or any letter standing alone has a power of 1. Because in form 2 we said any number or any letter raised power 1 will remain the letter of the number. Don't forget that. Mathematics are interconnected concepts. Then you must learn form 2, my friends. So this one has a power of 1. And we say in our statement, when we are differentiating, we say we are multiplying by the power and subtracting 1 from the power. Just understand. So here we have what? Let's say like this. We have 2x power 3 minus 8x. Remember here we have 1 which is hidden. So we say what? We are multiplying by the power and subtracting 1 from the power. So it will be 3 times 2x power 3 less 1. We are multiplying by the power and subtracting 1 from the power. Minus 1, because we take this one, we multiply, times 8x power 1 minus 1. So it will be what? 6, 3 times 2 is what? 6. X squared minus, look here, 1 times 8 is 8. X power 0 is what? It's 1. Any number or any letter raised to power 0, the answer is 1. So x power 0, 1. 1 times 8, it will be how much? 8. So this is what we are going to have. That will be our final answer for your information, guys. Okay? That will be our final answer for your information, guys. Okay, let's see example 2. Let's see this one. This is B, yeah? Let's see this one. We have 1 out of x power 3. Remember, this can be written as, x power negative 3. I think I've learned the rule of indices. Okay? So it will be x power negative 3. So we say that we are multiplying by the power and subtracting 1 from the power. So it will be multiply this one. Negative 3 dot means multiplication, x power negative 3 minus 1. Because we are multiplying by this power and subtracting 1 from the power. So it will be negative 3x power negative 4. Okay? Look at that. Or this can be written as, or reverse this one, it will be negative 3 all over x power 4. Why are we saying that? The moment you say divide, then the sign will be positive if it was negative, by the way. Okay? Let me add one more so that you understand better. Let me add one more. Look at this one. Let's come here. See, because of the reflection of the whiteboard, we have x power 4 minus 9x squared divided by x squared plus 3x x squared. So now, when you look at this one, you see now, unless you have the concept of quadratic of form 2 and form 3, you can't solve this one. Remember, let's try to solve this one. The upper one. Let me take solution. Let me take num. Now we can solve by using the difference of two squares. Don't forget that. So this can be written as x power 4 minus 9x squared can be written as 2x. Sorry, not 2x, sorry. X squared minus 3x, close the bracket, into x squared plus 3x. Look at that. The difference of two squares. Go back to form 2 concept of quadratic and form 3. Then therefore say num over then. So therefore we are going to say therefore num over then. Our num we have gotten as x squared minus 3x in bracket into x squared plus 3x divided by the denominator, which is x squared plus 3x. So you can cancel these two because they're same. Look at that. So I will have x squared minus 3x. Okay, differentiate this one. It will be 2x squared minus 1 minus 3 alone. So say x, let's say minus, because our power is hidden 1. 1 times, let me make this place very wide so you understand. So it's 1 times 3x power 1 minus 1. So it will be 2x alone. 2x alone minus 3. Final answer. It is very easy. We are multiplying by the power and subtracting 1 from the power. Just understand that, please. After knowing how to differentiate a given fraction, okay, the equation of a curve, then what we're going to do is actually, we'll go and see what we normally call equation of the tangent and normal to a curve. We must know what a tangent is and what a normal is. A normal line and a tangent line. In form 3, remember we said that a tangent is a line, it's a straight line which has 1 point of contact to the circle. Do you remember that? Yeah, okay? Do you remember that in form 3? A tangent is a line which is perpendicular to the radius of a circle. Look at that. That is form 1 statement of form 3 statement of mathematics, which is very significant in the concept of angle property. Yeah? Just understand that. Then here we will go ahead and see a question of a tangent and normal to the curve. That's what you're going to see, young man. Yeah, my young brothers and sisters. Let's see that. Make sure you follow me. You follow me so that you don't beat the bush, yeah? Follow me. Follow me. I know you have been stranded by this COVID-19 at your respective places. Make sure we solve together, yeah? At home level. So that, let's say we have a question of the tangent and normal to the curve and normal to a curve. This will be our next discussion. Equation of a tangent and normal to a curve. So we say that let's write an empire. The gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. How does that one is very important then. We are saying MB, the gradient of a curve at a point is equal to the gradient of the tangent at that point, yeah, to the curve at that point. Very, very important, by the way. Means the tangent has the same gradient with that of the curve. Just understand in simple language. They are saying the gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. What does it mean? So that means the gradient of the tangent is equal to, at the point of contact, where the tangent meets with the curve. We are saying the gradient of the tangent is equal to the gradient of the curve at the point of contact. See? Just understand. We are not writing this thing on the whiteboard because of money, but we are writing because of a reason. Just understand that. Because you are told the gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. That means the gradient of the curve and the gradient of the tangents are equal at the point of contact. Just understand that. Another one. What are we saying? Normal to the curve. And normal to the curve is the line which is perpendicular to the curve or to the tangent at that point of contact. What have I said? Normal to the curve is the line perpendicular to the curve or to the tangent at that point of what? Contact. Just understand, brothers and sisters. Differentiation is not hectic, by the way. People are making it very hard. Very, very easy. And as we go ahead, I'm sure I will marvelously do so many examples for you that has appeared once in KCSC. Then I'm sure you'll be in a position to solve such kind of questions in the math familiar. This book will help you. Basically, after giving you the general knowledge and respectable questions from the book, then I'm sure during KCSC, the questions will never be one which is strange to you by the. You'll be very, very much familiar with it. Understand? So normal to the curve. Let's write normal to the curve. Normal to the curve is the line perpendicular. Perpendicular to the curve. Or to the tangent. At that point. Period. What does it mean? If you have the gradient of the curve or the gradient of the tangent, you can say m1 times m2 is equal to -1 because the two lines are perpendicular to each other. Just understand. So you can say m1, which is the gradient of the curve given, or the gradient of the tangent given, multiplied by m2, the one you're looking for, which is the gradient of the what? Of the normal, is equal to what? -1. From there, you're going to get the gradient of the normal. So they say normal to the curve is the line perpendicular to the curve or to the tangent at that point. Two lines are perpendicular. We said in form 2. Two lines are perpendicular if the product of the gradient will give you what? -1. See? So if you have the gradient of the tangent or maybe the gradient of the curve, you can get the gradient of the normal by using that principle which says m1 times m2 is equal to what? -1, guys. Very, very easy. Okay? Just write this and it will help you. Make sure you write. Okay? So now let's see examples. Examples, yeah? Let's see example. Okay? Okay? You'll be given equation of a curve, then from there equations will come. Yeah? We'll also do from the main familiar, but for that, try this one. You're told the curve whose equation whose equation is y is equal to 3x squared minus 2x plus 1 passes through through a point to be given, through the point B, which is 1, 2. Full stop. Then you are told find, then colon, question A, the gradient function of the curve. The gradient function of the curve. Period. Question B, the equation of the tangent. The equation of the tangent. The equation of the tangent to the curve. At point B. Then the last question C, the equation of the normal to the curve at B. The equation of the normal. The equation of the normal to the curve at B. So 3 equations are there. You have the equation of the curve and a point, okay, where the curve with the equation 3x power 2 minus 2x plus 1 passes here, okay. So you have a point and an equation. So what you're going to do is, let me show you the right procedure. Look here, it is very, very easy, by the way. So far you can differentiate what a tangent and a normal to the curve is. It is very, very easy, guys. You should not be frustrated. This is a mathematics. So you need to what? You need to calculate and give time. So here we have the equation of the curve. Let's write that. Equation. Y is equal to what? Y is equal to 3x squared minus 2x plus 1. So the gradient function is the gradient function here we are talking about. Gradient function of the curve is the equation given differentiated. You only differentiate the equation. Then after you differentiate the equation, you are going to get what you normally call the gradient function. Just understand that, yeah? The gradient function. So when we are differentiating, we are saying dy over dx. And we are differentiating y with respect to x. Just understand that. Dy over dx. Just understand. So we want to differentiate this one. So from our previous example, we said we multiply by the power and subtract 1 from the power. So it will be 2 times 3x power 2 less 1 minus this one. It will be 2. Forget this one. Forget this one, yeah? So it will be 6x because 2 minus 1 is 1 minus 2. So that is the first answer. So this is what we normally call the gradient function. Okay? Very easy. You only differentiate. Dy over dx is equal to what? It's equal to blah blah. You differentiate that one. Okay? Yes. After that, okay? You are told again, this is the first, you are told the gradient function of the curve. That is the answer. You already differentiate the equation given. Question B, the equation of the tangent to the curve. When you want to get, we say there, a tangent and a curve have got same gradient at the point of what? Contact. So let me get, okay, a point is also given, not forget that. A point is also given. Okay, I will say gradient of the tangent. Gradient of the tangent at point of what? Contact, which is 1, 2. Okay? So what I will do is, you only substitute for you to get the gradient of the tangent. Because you want to get the equation, remember you're told the equation of the tangent. For you to get an equation, remember, you must have a point and a gradient. Right? From form 2 concept. So now, remember we said also, tangent and a curve have got the same gradient at the point of what? Contact. So let me substitute now the value of x here, x coordinate in the equation above. This one, the gradient function. So I will say 6 times 1 minus 2. It will be what? 6 minus 2, which is 4. So that's the gradient of the tangent. So from here, for you to get the equation, you can take this point, a general point, this point, a general point plus the gradient. That's from 2 concept, remember. So now, you can say, taking a general point together with blah blah, oh, you move like that. Ama, you can say, let x and y lie on the same line. Okay? So let me say, check it. Check it. A general point. Checking a general point, which is xy, together with, then I have a point in the gradient, together with b, which is 1, 2, and my gradient is what? 4. Let me get the equation. So I'll say y, which is the general one, y in the general point, minus the y value of the point taken, which is 2 now in this situation, divided by x less 1, which is this one, is equal to what? 4. So cross multiply, it will be y minus 2 is equal to 4x minus 4. Take this one. So y is equal to 4x minus 4 plus 2. So y is equal to 4x minus 2. May God bless it. That's how you're going to get. You take the gradient you have gotten. How have you gotten the gradient of the tangent? We substituted the value of x at the point given, here in the gradient function to get the gradient of the tangent. Just understand that. So let me solve C here. C, we are told the equation of the normal to the curve. You see what? A normal is the line which is perpendicular to the tangent or to the curve at that point of contact. So we say that they are perpendicular. So the normal is always perpendicular to the curve. But the tangent have got the same gradient with the curve. Yeah, with that of the curve. So I will say M1. This is M1, yeah? Remember. M1 times M2 is equal to negative 1. Remember they said at B, so we are going to take this point. So I know my M1 is what? 4 times M2 I don't have, is equal to negative 1. All of 4 cancel. So M2 is equal to negative a quarter. My brothers, I think that's very easy. Very, very easy. So you can go ahead and come here, say, because this information is somewhere here, let me wrap this part here. You have the question, I think. Let me wrap this part. So far you have the gradient. Then you can take this point. Another, you can say, let xy lie on the same line. Or you can say, taking a general point together with blah blah, you can write this one. You can also say, let xy lie on the same line, yeah? So you can say, y minus 2, which is this one, all over x minus 1 is equal to the gradient of the normal, which is negative a quarter, yeah? Then you cross multiply. It will be 4 into y minus 2 is equal to negative 1. Don't forget that. Negative 1 into x minus 1. We are crossing or what? Cross multiplying. Just understand. Very easy. So 4y minus 8 is equal to minus x plus 1. Negative 1 times x. Negative x, but negative 1 times negative 1, negative 1 times negative 1 is what? Positive 1. Don't forget that. So 4y is equal to negative x plus 1 plus 8. So 4y is equal to negative x plus 9. So root of 4, root of 4 throughout, root of 4. So y is equal to negative a quarter x plus 9 out of 4. Final answer. So are you getting this thing? Tangent is the line which has got the same gradient with the curve at the point of contact, while normal is the line which is perpendicular to the curve or to the tangent at the point of contact. Okay? That is the end. Next time you're going to see questions from a familiar. Don't forget that. Questions from a familiar. Okay? In our past cases. So otherwise, I wish you the best. Make sure please you subscribe our YouTube channel. It's an academic channel. I'm still stressing that one. It is an academic channel, but it's not one which is based on common issues. It is very helpful to you and to your brothers, to the upcoming generation, yeah? So make sure please you subscribe, share with your friends and family members. Otherwise, I wish you the best, guys.